Boom! Circles, back at it. All right, you got a fairly straightforward assignment today. A very easy equation governs this assignment. However, you got to be able to manipulate it. The general rule in this course is the easier the equation, the more we kind of tweak it. Might catch you sleeping. So you did that lab yesterday, lab 5.1, the virtual swinging the mass above the head. And this relates to that. We're getting into our unit on circles. And by the way, circular motion is also two-dimensional motion. So you've been doing 2D projectiles, like the angled launch, like the cliff launch. Now we're going to take 2D a little further and start doing some circular motion. So let's go over just the basics of this. 5 minutes, quick prep. Watch this video, it's important. And then you're going to do this W5.1. Do not just jump to W5.1 without watching this first. Okay, I guess if you never watched this, you wouldn't have heard that. All right, the first few questions are quite easy. Find the radius, find the circumference, find the diameter. By the way, the symbols you should be using from your reference table, radius, minuscule r. From your reference table, circumference is capital C. Not in your reference table, but strongly recommended, diameter should be capital D. Reason being, lowercase or minuscule d is used for distance and displacement. Don't want to confuse those two. Distance, displacement versus diameter are very different concepts when you're doing circular motion. We'll see how down below. All right, so this is pretty straightforward. If you need a little assistance here, there's a circumference equation on PRT5. Go look it up. PRT5 has some geometry on there, SOHCAHTOA, other such things. If you don't know what radius and diameter are, look them up. Okay, let's go down over here. Question 4, 5, 6, 7 then have to do with this scenario. Here you're given a different dimension of the circle. Pay attention to what it is. And again, you're asked for the radius, so R is what you're looking for. You're asked for the diameter. Make sure you use that as a capital D so you don't confuse it with distance or displacement. And finally, the circumference again. Okay, fine. Now, question 7, however, steps it up a little bit. Now we're actually going to put some physics on our math. So if the object were to move once around the full perimeter of the circle, what are we talking about here? You see the word sketch? Especially now moving forward. You need sketches. You need to get sketchy with your physics work. You need an organizing principle that allows you to basically frame each question to say, all right, wait a minute, what do I do next? This sketch is that something. How did you know to make an XYR chart? Put a little sketch, curved trajectory. You will see more and more in this course that that's not a unique situation for projectiles. It's all of the questions we do moving forward. You're going to want a sketch. So sketch them in there. Here, circular motion. So we can draw our center of our circle. It doesn't really matter which way this object's going around the circle. We'll have it go counterclockwise in this case. You'll see that it doesn't matter for this problem. Okay, so an object were to move once around the full perimeter of the circle. So let's start writing out what we got here. So it's going to move once around the full perimeter of the circle in a time of 10 seconds. What would be its average speed? All right. Well, it's not a bad thing to start with your question mark given. They're asking for average speed. Now, here's something also can help you. If you're not quite sure where to go with all this, what equations do you have available? Well, one equation we have is average speed. The first one on PRT6 is d over t. Another equation that I taught you is average speed equals VI plus VF over 2. Not in your reference table, only holds for constant acceleration. As it turns out, you most certainly don't know VI or VF. This one is not going to be of much use this unit. Okay, there are other reasons that one's not of much use this unit, but let's not worry about that for now. V bar is d over t. Okay, so we can use that. Now d, minuscule d for distance. Distance equals. This is where the sketch comes in. It says the object moves once around the perimeter of the circle. That means if you sketch this, the object did this. What is that distance? The object followed a circle. That's why I don't want you confused. Big D, little d here. What is that distance? It's not a radius. It's not a diameter. It's a circumference. And in fact, you found the circumference in question 6, which then will get input right here. That distance actually is the circumference, which is whatever you came up with. This is where the sketch assists you. Additionally, when looking for the time, well, you must coordinate your givens. This distance was for one time around the circle. So the time should be for one trip or one time around the circle. And they actually tell you to go all the way around this circle once takes 10 seconds. Now, you did Lab 5.1. In Lab 5.1, we gave a name for that time to go once around. That name was the period, which is represented by capital T, which you actually also will see on PRT 5. So let's frame everything we got here. You have enough math, you have enough givens to do the equation and get the answer. But I want you to recognize something here that's very important. That something is, when you're doing V bar equals D over T, it is worth your while to recognize that a common way we will do this is to see that the distance and the time, when going once around a circle, the distance is what we call the circumference. The time is what we call the period. And so this equation is exactly equal to circumference over period as well. And that's often the way that you're going to do this. So I'll make this black so it doesn't interfere with the green equals. Okay? The way you'll often do this is, yes, D over T, but by way of your sketch, recognize that D is usually the circumference, T is usually the period. Boom, plug it in, get your answer. If you don't do that, you run a risk. The risk is you take any old thing with meters on it, any old physical quantity with meters on it, slap it in the numerator, put your 10 in the denominator, and then you have a little gander down at the key. And you're like, oh, it says 1.4. 1.4, I don't need to calculate it. But you do need to calculate it because that's what you have to use to verify. You look down at the key and say, wait a minute, how is it that I got 0.6? Meanwhile, it's supposed to be 1.4. That should bring you back and say, wait a minute, did I do these givens properly? Okay. Now, this note right here, please take this note seriously. Go and check the key. Make sure you did these correctly. You actually have to do it. Now, what you'll find on the remaining questions, 8 through whatever it is, 12, is they are essentially, draw your sketch, a manipulation of V bar equals D over T. You should find the math here very easy. The only part you have to watch out for is what are the givens. So here you're provided a circumference, and here you're provided a time, but be mindful of the units. Remember what we said. Easy math, it's going to get a little tricky on you. It's going to play a little game on you. Here the little game is, of course, the unit came in minutes, and we don't want this in minutes. On the back, same sort of business. Look what you're provided. You're provided now a radius and a time. Well, that's cool. The time is 30 seconds, but the radius is not the distance around a circle. So you're going to have to make an adjustment there. And so you'll notice each of these requires some sort of adjustment. These are not tough questions, but you must be disciplined about your givens. Be sharp on this, knock it out. And if you didn't finish Lab 5.1, you need to knock that out too.